Let's begin. Today's November 17th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 13, 16, 18, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally, criteria card F. Criteria card A takes a look at our first digit and compares its value to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B will take a look at our middle and last digits, square and circle, and compare them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card C will take a look at our 3-digit solution, and the Turing Machine will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card D will take a look at our 3 digits, triangle, square, and circle, add them together, and the Turing Machine will let us know if that sum total is an even quantity or an odd quantity. Criteria card E will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F again takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure. Specifically, it can tell us whether it has no repetitions, as in the example 1, 2, 5, or it could tell us that it might be a double number, meaning it has a single digit repeated as 1, 1, 2, or it could also tell us that it could be a triple number, a single digit repeated 3 times, as in the example 2, 2, 2. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card C. Okay, so the Turing Machine approves of my choice in my proposal 314. Notice that I do have 2 odds to a single even. Since the Turing Machine approves of that, it's letting us know that there should be less even than odds. So let's go ahead and type that up in our notes. And we'll say that evens are less than odds. Next, I think I'll test criteria card D. Okay, so the Turing Machine does not approve of my choice in 314. Notice we are adding all the digits up. So let's go ahead and do that. So if we add 3 plus 1, that's 4. 4 plus 4 is 8. 8 is an even quantity, but the Turing Machine does not approve of that. So it's letting us know that the sum total should actually be odd. So let's go ahead and type that up in the notes in section D. And that again is that triangle plus square plus circle should be an odd quantity. And so what can that tell us? Well, notice that again, or remember that we did establish from criteria card C that there should be a majority of odds. So that means that we have at least 2 odds and maybe an even or an odd as a 3rd digit. So if you have 2 odds, that sum thus far, when you add 2 odds up, that's an even quantity. But if we want the sum total to be odd, that means we have to add 3 odd digits together. So actually, our solution here, I'm going to add an additional note, is 3 odds. Okay, so in combination with C and D, we've established that we're looking at a 3-odd solution. So no evens. So let's go ahead and cross out all the evens in triangle, square, and circle. Okay, so the question is, could there be could there be no repetitions, or is there a double number? And what is worth testing? I've said in the past that we could do criteria card E, the sum of the first 2 digits in the first round, so that maybe we have to retest it. Let's see. So currently I do have a sum of 4, and it would be 1 3 or 3 1, or it could be even 1 1. That's what a check would it would represent, those potential solutions. So we still, we could have a sum of 6 or even greater than. But yeah, let's go ahead and test criteria card E. Okay, so yes, so the sum of the first 2 digits, 3 plus 1 is 4, 4 is less than 6, and the Turing Machine does approve of that. Okay, so let's add that to the notes in section E. And so triangle plus square should be less than 6. So that was very fortunate. And so what does that say? If the sum of the first 2 digits must be less than 6. If you remember, I did not mention 5 at all. So yeah, so 5 plus even the smallest of 1 gives us already something greater than 6. So triangle, neither triangle nor square can be 5. Okay. And yeah, so we still have possibilities, as I mentioned. It could be 1 1 or some kind of combination of 1 and 3 for the first 2 digits. Okay. All right. Well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A comparing triangle to the number 3. So at this point, it's a 50-50. It's either going to be equal to 3 or smaller than 3. So that's good. We also did not test criteria card B comparing our middle and last digit, the square and circle. Obviously, we could have, a pair, right? That's where maybe we have a pair, and that's what criteria card F will check, whether we have no repetitions or a double number. Could we have a triple number? Is that possible? Yeah, well, all the 1s and all the 3s are still in play. So that's possible. Let's see. Well, so I guess the question is, what if, well, I don't think you could have a triple number, and this is the reason why I think you can't have a triple number. If you have a triple number, then you automatically already know that square and circle must be equal. And if that's the case, then this card really becomes irrelevant. So I don't think, or it's for that reason that I don't think you're going to have a triple number. You could still have no repetitions, and that would keep the 5 in play in circle. But you could have a double number in either 1s or 3s. Obviously, it wouldn't be 3 3 because that would give you a sum of 6. But either circle could either be a 1 or a 3 if there is a double. Okay, so what's the most likely? The most likely is it's going to be some kind of combination of 1 and 3 in triangle and square, and then I guess that pair based on let's see, what could square, I guess, yeah, I guess square could be a 1 because you could always pair it up with a 1 in circle. But let's go ahead, let's see, do we want to pair? If we choose a pair, we're basically saying that circle can't be 5. And if that fails and it results in no repetition, then again, 5 is in play. So how would you distinguish? So you need to somehow distinguish, well, or do you? Yeah, a triangle will define itself based on criteria card A. Okay, so let's do 3, 1, 3. Let's see what happens there. And just to double check, yeah, they're all odd. The sum is odd, or there are more odds than evens, I should say. And the sum is less than 6. All right, let's go with that. All right. Yeah, so since triangle is pretty much independent, you really do have to test it. I don't think you can deduce that. So let's go ahead and test A. Okay, so I chose a 3 for triangle. That is not correct. So I'm going to go ahead and deduce that triangle should actually be less than 3. So let's go ahead and type that up in our notes. And that is in section A. And we'll say, oops. We'll say we're going to deduce that triangle should be less than 3. Okay, so not a 3, so let's go ahead and cross it out. And let's see, before we compare square and circle, I think let's go ahead and test criteria card F. Okay, so it is true that there should be a pair. Okay, so let's go ahead and type that up in our notes in section F. And we'll say that the solution has a pair. Okay, so we do have a pair. Well, I guess, let's see. Yeah, I was thinking that maybe we could remove the circle 5 from play, but that's not the case. You could still have technically 1, 1, 5. But if that's the case, yeah, I don't think it can be 1, 1, 5 because the only possibilities there, again, I'm thinking it's not going to be, well, we know it's not a triple number. We've already established there is a pair. So how would you choose between 3 and 5? I don't see any way, because in this case, if it is 1, 1, that would mean 1 is obviously smaller than circle, can't be equal. But that doesn't really tell you how to pick between 3 and 5. So I don't think it can be 1, 1 as the pair. Let's see, is it worth, let's see if we can write some of these possibilities out. So again, it's not 1, 1, but what about 1, 3, 1? So it could be 1, 3, 1. It could also be 1, 3, 3. And I think that might be it for triangle 1. Let's see, 1, 1, 3, 1, 1, 3, 3. And yeah, actually that may be it for any kind of ones. Yeah, because obviously you can't have square and circle be 1. That would force triangle to be a 1, and that'd be a triple number. That's not possible. So, yeah, it looks like 1, 3, 3, 1, 3, 1. Okay, and then, well, yeah, actually, maybe that does exclude 5. How could you, yeah, we excluded 1, 1, 3 and 1, 1, 5 because they would be ambiguous. So, yeah, well, yeah, of course, 1 is, triangle has to be a 1. That's the only thing remaining, yeah. So either square is 1 or it's not. So yeah, 1, 3, 1. Yeah, so that looks like it. And yeah, we have to decide, I guess, are square and circle equal in the case of 3, 3, or is square greater? And I don't think there's a way to deduce that. So yeah, I think we're just going to have to test B. Okay, so it is not the case that circle should be greater. So in my proposal, I've got a 1 for square and 3 for circle. So it's not the case that square is greater. So let's see, can square be equal to? Uh-oh. Let's see, what's going on? Oh. Oh, no, 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 no. Yeah, I think, yeah, I should have realized I should not have run criteria card B in this round because it was obviously wrong. I couldn't have this, or this proposal could not be the solution. It's not one of the two. So I should have just gone straight to the third round and say, I mean, sure, I would have wasted a turn in the second round, but at least I would have been at 6 tests, not 7. So now I've got to go to the third round. Oh no. Okay, well, I will, instead of typing up all that, let me just go to the third round and we'll say 1, 3, 3 as a potential solution. I should have noticed that. Okay, so we'll retest B. And yes, they are equal. So here I'll say that square equals circle. And so that would mean that the solution seems to be 1, 3, 3. So let's just confirm. Again, they're equal. So yeah, so that would mean that it can't be 1, 3, 1. And because they are equal, so that would mean that, yeah, you can't have 5. But I should have actually crossed that out much earlier. So that means that it can't be the 1, 1 for square and circle. It's got to be the 3, 3. So yeah, so let's cross out the 1 in circle as well as the 1 in square. And so yeah, it looks like the solution should be 1, 3, 3. And let's just quickly verify So we deduce that the first value triangle should be less than 3. It is. The middle and last are equal. They are. We have 3 odds. We do. And that's because the sum of the 3 odds is odd. And the sum of the first 2 is less than 6. And we do have a pair. Okay. Well, it looks like that should be the solution. But let's go verify. And that was 133. Well, fantastic. And how do we do versus the Turing machine? Well, I am a bit concerned because we did go to 3 rounds and 7 tests. Hopefully, I'm hoping that we tied it, but we'll see. So in the first round, we did C, D, E. And in the second round, we did the remaining 3 and retested B in the third round. That may have cost us. If we do lose, it's because of that unfortunate oversight. So let's go ahead and type this up. So C, D, E in the first round, and then the remaining 3 in the second and B in the third. So C, D, E. So C was correct, D I believe was incorrect, E was correct, and I think both A and B were incorrect, but we did have that pair, so that was correct, and then we finally got B correct. Wow, so we still beat the Turing machine by 1 question. Well, again, I think we could have done it in 6 had I not looked over the fact that my proposal would have failed. It was not one of the last 2 potential solutions, so it wasn't worth testing, at least not in the second round. Changing the proposal in the third round, I would have picked one that, could have still been wrong, but at least it would have been a 50-50 at that point. Okay, well, lesson learned. So how about you? How did you solve it? Did you pick a different set of criteria cards, and did you discover anything interesting? Add your thoughts to the comments. If you did like the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.